stopping you. All right, so lots of stuff to get through today, even though there's really not a lot of actual notes today. But the notes are kind of involved today because we're switching up from just regular vectors to vectors using navigation, or we're using vectors in navigation for us. Okay? Just looking ahead to the next 3 weeks, I can say 3 weeks, T, because guess what? There's a spring break week in there too. So this week, we're going to talk vector navigation pretty much all week long. Thursday, we're going to do a quick solve. And trust me, we'll have class tomorrow. Okay, we'll have class tomorrow. So don't be wishing and hoping for a snow day tomorrow. That's probably not going to happen. Okay. And then this week, Friday, we're going to take formative. Okay. So if you are going to leave early for spring break, okay, make sure that you let us know so we can get a copy of that formative in the resource center for you prior to, so you can take it yet this week. I wouldn't take it today because there is a vector navigation problem on it. So I would wait until Wednesday afternoon or Thursday to take it. That's just me, crazy like that. Okay. Then next week we're off. Okay, no classes next week. And then the week that we come back, so we'll come back, our next class then after spring break will be on April Fool's Day. You still have to come to class. Okay, all right. And we'll talk more about vector navigation problems that day. Then we'll do a review day on that Wednesday the 2nd. And your test for this unit on vectors and navigation and all that fun stuff will be on Thursday, April 3rd. Okay? Okay? With that being said, we have one multiple forces warm-up problem for you to do from our last class on Friday. Okay? A soccer ball is acted upon by two forces. The first is a force of 314 newtons at a direction of 45 degrees. The second force is a force of 272 newtons at a direction of 135 degrees. Find the direction and magnitude of the ball. Basically, the resultant vector would be of the ball. Okay? Good warm-up problem. Let you have at it. Go. So force 1 is going to have a force of 314 newtons at a direction of 45 degrees. Oops. Classic. Oh, what is 314 divided by 2? 157? Okay. And then we've got the second force. We say 272. Oh, what's 272 divided by 2? 136. Okay. So then my resultant force magnitude a magnitude of 415.427 newtons. Yes? Yeah? Okay. Since that's in quadrant 1, I get a direction angle of 85.901 degrees. Yes? Questions, comments, concerns, clarifications? They make it in there, so. You know that they're posted online too, right? Every day. Every day. Good. All right, let's go on. Let's get to some navigation. Okay. So again, I remind you that in navigation, north is up and it is 0 degrees. Okay, it's been a while since we've talked about this. Okay. East is right and it is 90 degrees. South is down and it's 180 degrees. West is left and that is 270 degrees. Okay. Remember that navigation can come in 2 different forms. Okay? The forms that it can come in is it can come as a degree, or it could come as the north-south degree east-west angle. Both of those are the same bearing navigation heading angle. Okay? Both of those would be down here, where this is a 10-degree angle then, or this is 170 degrees in terms of that. Okay? In both of those cases, you are going to need to, oops, I forgot the V in convert. You are going to need to convert either one of those into a trig angle for calculations. Which means that this one would be then as a trig angle 280 degrees for both of those. Okay? Which is why we spent time converting between the 4 different ones. At the very end, then, you are going to want to give your answer in the form of your navigation from the problem. Meaning, if your answer, if the problem said 170 degrees, we would want your bearing or your heading that you're trying to find in that navigation straight up one. If your answer, if the problem comes as south 10 degrees east, then we need you to convert your answer, your navigation answer, into that form also. Okay? Whichever form the problem is, that's the form we want the answer in. Okay? Now, this next part is what you are going to need to flat out, to make your lives easier, you're going to flat out memorize this next part. Vector A plus vector W equals vector G. Okay? We're going to be talking, some of you are going to be getting on an airplane next week and flying somewhere, hopefully warm. Okay? Your pilot does this, actually the computers on the plane do this calculations constantly. Okay? A stands for your airspeed or your speed. Or we can use boats because we can use currents or all that stuff. So it's basically whatever vessel you're traveling in, that's what your A is. Your W is going to be your wind or your current. Okay? Wind if you're on a plane, current if you're on a boat. Okay? And G is going to be your actual speed and direction. Okay? If the wind is behind me and blowing in the same direction that I'm going, when I set my speed, it's going to make me go faster because that wind is going to be pushing me. Okay? If it's blowing at me, it's going to be slowing me down. Okay? Unless I make adjustments to that. Okay? So that's what that's going to come into play. All right? Let's dive into the first one. A plane has an airspeed of 450 miles per hour and a bearing of 150 degrees. The wind is blowing with a bearing of 60 degrees at a velocity of 50 miles per hour. What is the true course and the ground speed? Okay, let's break this up into two parts. Is that A, W, or G? That's A. Okay. What is this one? W. Actually, I should have made that one be green. Okay. So this is A, and this is W. We want to find G. Okay? So, let's break it down. Let's deal with A first. A has a magnitude of 450 and a bearing of 150. So my 150 would be down here, where this would be 150 degrees. Do we all agree with that? Okay. What would the trig angle be for my A? It would be 300 degrees. Rach, the trig angle comes from here all the way around to there.
Oh, okay. Thank you.
Okay. So my vector A then is going to have the component form of 450 times the cosine of 300 degrees, 450 times the sine of 300 degrees. .450 cosine of 300 is 225. 450 sine of 300 is negative 225 square roots of 3. Okay, so that's my vector A. Now we need to come up with our vector W for the wind. Wind is blowing with a bearing of 60 degrees. What would my trig angle be here? 30? It said 50 cosine of 30, 50 sine of 30. I get those. Yes? Agree? Okay. So my resultant vector then is going to be, or what I told you to memorize is A plus W equals G. I've got A, I've got W, we need to find G. So my resultant vector here is going to be 225 plus 25 square roots of 3, comma, negative 225 square roots of 3 plus 25. Which is going to be approximately 268.301 and negative 364.711. From that vector now, we need to find the magnitude. So that's going to be 268.301 squared plus negative 364.711 squared. And then we're going to take the square root of that. I get 452.7693. We also need to find the reference angle for G. I get a reference angle here of 53.6598 degrees. Yes? My resultant vector G is in the fourth quadrant, which means this angle here is theta prime. Yes? Which is going to make I'm going to add 90 to that. So that gives me 143.660 degrees as my bearing. Questions, comments, concerns, clarifications? Yes, ma'am.
How do you know that's in the fourth quadrant?
Because it's my vector is positive, negative.
Okay, thank you.
And we can't go off of our old, in quadrant 4, it's 360 minus my reference angle because we need it to be a bearing angle now. Okay? So that's why I added 90 to it, because this 90 from here so I needed to go 90 plus my reference angle. A plane is flying with a bearing of 300 degrees with a velocity of 500 miles per hour. Because of the wind, the plane has a resultant vector of 525 miles per hour and a bearing of 305 degrees. Find the velocity and the bearing of the wind. Okay? Get it set up, and then I'll jump back in and I'll make sure that we're all on the right page, and then we can find velocity and bearing of the wind. So my A vector, 300, would be here, which would be a trig angle then of 150. So vector A then would be that which is going to be that. Agree with that one. Speak now, forever hold your peace. Okay. The other one that's given to us is G. G has a 305 degree bearing, which would make my trig angle be 145 degrees. So my G angle is going to be 525 cosine of 145, 525 sine of 145, which is going to make that one be negative 430, 055, and 301, 128. Let me make sure that that's what I got here. Negative 430, 055, 301, 128. Yes. Except I got a bad 5 going on in here. There we go. A plus W is equal to G. If that's the case, yes, then W is going to be G minus A. Would you agree with that? I can subtract that vector from both sides. So I'm going to actually subtract going up. So my vector W is going to be, so that was for me, it was O minus A, 2.9579, and 51.1276 for my resultant, or excuse me, for my wind vector. Talk to me.
Wouldn't it be negative 43.055? Oh, then you add that.
Minus a negative 250 square roots of 3, yes. So that gets me 2.9579. Okay? Find me the direction, the velocity, etc. of the wind. I get the wind is blowing at 51.213 miles per hour at a bearing angle of 3.311 degrees. Lay it on me.
How'd you get the bearing?
Well, do you agree with how I found my reference angle?
Yeah.
Okay. Do you agree that this angle is in quadrant number 1?
Yeah.
Yes. So that would put where I have it right here. That would make my reference angle be right there, right? Okay. So my bearing angle is going to come from here to there.
Okay.
So I'm going to subtract that from 90. Yes? Love it. Oh, smell it. That's it? Nice. Perfect. It gives me time to hand stuff back.